Good evening and welcome to Roundtable. Today with us we have Mr. Satis Arnold, and he is a construction management specialist, a higher education policy expert, and also he is here in Sri Lanka from Australia as a team leader for an ADB funded project, and it's called Education for Knowledge Society project. So good evening, Satis.
Good evening.
And thank you for accepting this invitation at such short notice.
It's my pleasure.
And also tonight we are going to discuss climate change and adaptability to Sri Lanka, Satis. So how are you interested in this field? And you said you're also doing some research work in this regard. What is the background to this particular interest?
Well, I've been interested in the effect of science and technology on society and environment from my school days in Colombo and my university days in Peradeniya and Sydney. I became a civil engineer and later a higher education policy expert. And finally, 4 or 5 years ago, while I was director of policy at Murdoch University in Perth in Australia, I decided that the climate issue is a very serious issue and I should take a much greater interest in it. So what I did was I traveled through the great centers of learning, the great universities that had great climate experts in the US, both East Coast and West Coast, and the UK, and also throughout Australia. And I then developed some proposals for climate-related work for universities in Australia, the Australian National University, Murdoch University, and Curtin University. And 2 years ago, I was director of the Sustainable Development Institute at Curtin, doing that kind of work. And now that I'm in Sri Lanka, I have been lecturing on climate change at two institutions and universities, and I still give lectures at Curtin via Skype and so on, remotely from here.
Right, Satis. So now getting on to the issue of climate change, what exactly is climate change and what is causing it?
Well, climate change is a very ancient thing. It's as old as the planet Earth. That's 4,500 million years old. And various natural causes have caused climate change for all that time, like extraterrestrial impacts, great volcanic eruptions, slight changes in the Earth's orbit, changes in solar activity. All these things have caused climate change on planet Earth. But we've had a period of great climate stability in the recent geological period of the last 10 or 12,000 years called the Holocene. This is after all the great ice ages were over, and we had this wonderfully stable 10,000 years when human civilization began to flourish. So we've had great climate stability. Now, during that period, civilization has risen to the point where we are now. But then as part of that advancement, we also started to burn fossil fuels with the Industrial Revolution about 200 years ago. And that has been the problem, where now we are threatened with climate change that for the first time is human-induced by the burning of fossil fuels and emission of carbon dioxide and other gases, and also the destruction of forests, which is having the same kind of emissions.
Now you said there was a remarkable period where there was stability in the climate. What did you mean by this? Are you referring to carbon dioxide emissions and content in the atmosphere? Is it one key indicator as well you're referring to?
Absolutely. For simplicity, just the carbon dioxide concentration in the atmosphere is a very good indicator of temperature. So that if our planet had no carbon dioxide in the air, then it would be not possible to live here because it would be below freezing point and we'd all be freezing. So carbon dioxide keeps the planet warm, and it's a very good thing. So in fact, in these last 10,000 years, the concentration has been pretty close to 280 molecules for every million molecules, parts per million, all that time, plus or minus 10 maybe. And that being the key variable, it has kept the global mean average temperature at around 15 degrees Celsius. If you average it across the seasons and if you average it across the latitudes, then it's been about 15 degrees all that time. And But just in the last 200 years, we've started to change all that.
Now what is like the ratio?
It's now
and what is-
392.
So we were first talking about 280.
80. Just in the last 100 years, we've basically taken it from 280 to 390.
Right. So like if you look at this particular climate change we're referring to, how can we apply this to the Sri Lankan context?
Well, I mean, obviously, the whole world is one, and whatever happens in any part of the planet begins to affect every other part of the planet. So if there is a lot of forest destruction going on in Indonesia, it doesn't only affect Indonesia, it affects the whole planet. And indeed, in around 1997-98, the seasonal burning got out of control, and the whole of Southeast Asia was blanketed with smoke from the forest burning in Indonesia. And that year, the total emissions load on the planet increased so much that it was noticeable on all the indicators. So, in other words, the world is interconnected. So, when you ask about Sri Lanka, we are affected by what the rest of the planet is doing.
But in terms of our contribution to the climate change, in terms of maybe carbon dioxide emissions, what is our contribution in terms of that indicator?
This is a very good point. When the rich countries tell us you should also help to reduce emissions to developing countries like Sri Lanka, there is a question of justice here, climate justice, because the average emissions per Sri Lankan person is only about half a ton per annum.
So now you have also been in Australia, right? And Australia also have more or less the same population, like 20 million. How do we compare with a country like Australia?
Well, it's a very good point, because Sri Lanka is at the very low end at half a ton per person, and Australia and the United States is at the really at the top end at about 20 tons per person. So it would take 40 years of emissions by Sri Lankans to do the same damage as Australia would do in 1 year.
40 years as opposed to 1 year.
Correct.
Half a ton to 20 tons.
Right, right.
So are you saying, if you like look at these statistics, are you saying when it comes to Sri Lanka, our role might be not so much in mitigating climate change, because our contribution to the catastrophic impact might be comparatively less? Am I getting the right implication here?
This is quite right, because when countries like Sri Lanka still are trying to complete electrification of all of our villages, I mean, we are about 80-90% electrified, but there's still 10-15% of the people who don't have electricity. And that means we need to actually consume a little bit more energy just to get basic needs for our people. So the question of climate justice is that when the world does a climate deal, that countries that are developing are allowed to get a bit more developed, and rather than being held down to where they are. Whereas the countries that are doing the massive pollution, like Australia and the United States and Japan and Europe, they have to actually learn to cut it down a lot, because the global average is about 4.5 tons per person.
But having said that, as Sri Lanka, like what is our role? Like what should we do with respect to climate change? Because as you said, we are part and parcel of the globe, and it's interconnected, and we are going to be affected, and we are. So in that sense, what should be our strategy?
I think as between mitigation, which is to reduce emissions, and adaptation, which is to learn to live with it, I think definitely our strategy as a relatively small country has to be to learn to live with it. That is really clever adaptation strategies for Sri Lanka.
So how do you define adaptation? What is adaptation?
In a very simple way, it is learning to live the best you can with the climate change that is coming, which is beyond our control. And even though it is beyond our control, the way we can live with it is very much in our control. For example, we could learn that in our dry zone there might be less rain, so we could have getting ready to develop crop varieties and irrigation techniques that require less water.
Right, so it's a point we need to elaborate on, Satis. We'll take a small break and we will be back with you soon.